Hi, I'm Greg and welcome to What's Old is New again. In this video, the What's Old part is really old. In fact, you can't get much older here on Earth. We're talking billions of years with a B. You see, something is weird with the planet Earth. It was brought to my attention by this book, Everything You Know Is Still Wrong by Lloyd Pye. Now, I want to explicitly say I am not on board with all the conclusions in the book. Nonetheless, the issues that are pointed out are definitely intriguing and warrant a closer look. The book points out that Earth is unique among rocky terrestrial objects with its plates and plate tectonics. What does that mean? And more importantly, what could have caused it? That's what I'm going to discuss today. So let's get into it. This colorized image shows Earth with the water removed. You can see the continents and the surrounding continental shelves extending out beyond the coastal edges. The darker blue shows where the oceans would be. The entire surface of the Earth is composed of various tectonic plates, of which there are two types. First is the thicker and lighter continental plates, providing dry land. Then there are the thinner but more denser, and therefore heavier, oceanic plates. These things jostle and move around all over the planet and give us things like plate tectonics and earthquakes. Now, scientists have spent plenty of time studying these topics, so they're well understood on a fundamental level. But what is barely discussed at all is why do these things exist in the first place? They are simply taken for granted. What do I mean by that? The plates are taken for granted. Take the moon, for example. Its crust is contiguous and locked in. It doesn't exhibit tectonic activity. It just kind of sits there receiving the occasional meteor impact. No continental versus oceanic plates. Here's the planet Mercury. Again, a simple contiguous crust. It has a stagnant lid that doesn't shift around. Mars is no different. It exhibits the giant scar of the Valles Marineris, but that is not a fault line or a plate boundary. Here is an image of Venus with the atmosphere and clouds removed. No different. No two types of plates. Let's look at Jupiter's moon Ganymede. Again, a solid shell of crust. I could go on, but do you get the point? So why is Earth different? In his book, Pye refers to Zecharia Sitchin's work on ancient Babylonian myth and the story of the battle between Tiamat and Marduk. He states that the battle between these primordial gods was metaphorical and was actually the collision between the protoplanet Tiamat and rogue planet Nibiru, which is Marduk. I'm oversimplifying it a bit, but this concludes with Tiamat becoming Earth and the moon and the asteroid belt becoming the rest, the remains of the collision. There are plenty of videos about this online if you wish to take a deeper dive. Now, I understand this is really far off. I mean, how could the Babylonians know about what happened billions of years ago? You'd be hard-pressed to find information on this online without finding the words pseudoscientific, controversial, and fringe. Despite being flat-out dismissed by science, the story gives a plausible explanation for the multiple types of continental shelves and why they exist on Earth. So let's look to see if this is possible, and then look at how the mainstream actually accepts a planetary collision theory. Compare a loaf of crusty bread to the Earth. The bread's crust forms from the heat of the hearth, as the Earth's crust forms as its molten protomass cools and coagulates. Both a solid, contiguous, rigid mass over a soft interior. Then catastrophe strikes, a glancing blow from another object of comparable mass. This rips a chunk of the Earth-bred mass off and leaves a gaping wound. As the Earth continues to cool, or the bread continues to bake, a new crust will begin to form over the wound. In both cases, the new crust is noticeably different from the old crust. In both cases, it's thinner and lower in elevation than the original. There are two differences in the case of the Earth, however. First, consider the Earth as a molten mass. As it forms, the heavier parts sink to the center and the lighter parts remain near the surface. As a consequence of this, the newer crust, made from material lower down, is denser than the original, just like the lower oceanic crust is denser than the higher continental crust. Secondly, the bread's interior is a solid mass where the Earth's core is molten and dynamic. The result of this is plate tectonics and the shifting around of the Earth's crust as we know, thanks to Alfred Wegener. Not so with the bread. So to me, this is a good explanation of what could have led to the Earth as we know it today, even though the details of the story are likely off. As I said, the whole theory is dismissed out of hand by the scientific community. But have you heard of the Theia hypothesis? It's the theory that the moon was created in a collision between the primordial Earth and another planetary body, Theia, way back in the day. A study providing evidence for this was published in the journal Nature in November of 2023. The study details proof of this in the form of something called large low-velocity provinces, or LLVPs. These are large areas found deep in the Earth's mantle that are denser than the rest. It's almost like planetary collision forming moon, yes. Planetary collision forming plates, no. Well, why not both? I think one follows neatly from the other. So we've seen that the Earth did not end up like the other planets. Science has paid little attention as to why thus far, but we are provided with an explanation from ancient literature. And while this doesn't provide proof, anyone can come up with an idea, and this one is plausible to me. Unfortunately, finding direct evidence of events from a few billion years ago is hard to come by. This explanation also explains the origin of the moon, if only science would think about connecting the two ideas. This is like the Younger Dryas impact hypothesis, which explains the black mat, the sudden temperature change, the extinction of the megafauna, the presence of impact proxies, the meltwater pulse, but that's another video. To me, a single event having multiple outcomes makes more common sense than having to find a separate cause for each event. But what do you think?